Hi everyone, it's Jeff from Transient Specialists. Thanks for joining us today. Today we're going to be spending some time on electromagnetic clamps, commonly just called EM clamps. We'll start by going over a little bit about the equipment, then we'll go ahead and take a look at the clamps and the related accessories, and then finally we'll spend some time on the setups. EM clamps are one of the injection methods of IEC 61000-4-6 for conducted RF immunity testing. As with other injection methods, a calibration is done prior to conducting testing, and then that level is then applied during the test. There's a couple unique features of most EM clamps, the first of which is being able to test multiple types of cables, and the second is the frequency. This offers the ability to meet IEC 61000-4-6 requirements, as well as offer a potential solution for troubleshooting and replicating failures between 400 MHz to 1000 MHz. Let's go ahead now and start by taking a look at some of the electrical specifications for a typical EM clamp. Now we're looking at the data sheet for the TESSEC KEMZ801A. We have our specifications in the middle with the frequency range, nominal impedance, connector, maximum input power, as well as other criteria. Keep in mind that certain characteristics of these clamps are dictated by IEC 61000-4-6, so many models will share somewhat similar specifications. As we mentioned earlier, many of the EM clamps have usable frequency ranges up to 1000 MHz. Taking a look at our technical specifications now, the KEMZ 801A has a usable frequency range from 10 kHz to 1000 MHz. Taking a look a little lower on our technical specifications, we have our maximum input power level. You can see that at the 10 kHz to 1000 MHz, the KEMZ can handle 100 watts for 15 minutes, and as the frequency goes higher, the power level decreases. From 230 MHz to 1000 MHz, it's only able to handle 50 watts for 3 minutes. Another important characteristic is the maximum cable diameter, which as you can see is 20 millimeters for the KEMZ 801A. The maximum cable diameter doesn't vary much between clamps, and they'll often be within a few millimeters of each other. If we take a look a little lower in the document, we can see the typical power requirements across the frequency range of operation to meet different test levels of IEC 61000-4-6, both with and without modulation. If we scroll a little lower, we can see we have a setup of the calibration or test level setting, which we'll go over here shortly. Let's start by taking a look at some of the EM clamps as well as the commonly used accessories. We have the EM clamps as well as the commonly needed accessories. Let's go ahead and let's start on the left with our TESSEC equipment, and let's work our way right. As we work our way right through the equipment, keep in mind that the test or stress level setting adapter kits will be needed for IEC 61000-4-6 testing and should be purchased in advance with the clamp in order to prevent delays. On the far left, we have the calibration adapters and rod called the CAL KEMZ for the TESSEC EM clamp. This might be needed if the calibration facility you're using doesn't have them, or you plan on verifying some of the characteristics of the clamp internally. As you can see, these are a different design from that of the test level setting adapters. These adapters also require different connectors on the rod which is placed in the clamp, which is included in the CAL KEMZ kit. Just to the right of our calibration adapters, we have our test level setting adapters along with our 50 ohm termination load. As we mentioned before, if testing is going to be conducted to IEC 61000-4-6, the adapters and related equipment will be needed. Behind our adapters, we have the TESSEC KEMZ 801A EM clamp. Looking on the right side now, we have the Luthi EM101 and our related accessories. As you can see, in front of the EM101, we have the stress level setting equipment, and then on the far right, we have the FTC 101 decoupling clamp. The FTC 101 decoupling clamp provides isolation between the injection clamp and auxiliary equipment. This helps ensure that other connected equipment is not exposed to the stress level of the equipment under test. Let's take a look at the calibration setup using the TESIC KEMZ 801A. Now we're taking a look at the setup for the test level setting or calibration in accordance with IEC 61000-4-6 as illustrated in the data sheet. Starting from the output of our conducted RF test system, we have that connected to the 6 dB attenuator. From the 6 dB attenuator, we have that going to the input on our KEMZ 801A. Taking a look now, on the left side of our clamp, we have our 50 ohm termination load connected to our CAL 801A 100 ohm adapter. We have that adapter connected to the rod, which is going through the KEMZ 801A. On the right side of our KEMZ 801A, we have our other 100 ohm CAL 801A adapter, and then we have that connected to our channel 1 power meter on our TESIC NSG 4070 test system. While the models of equipment may vary slightly between different manufacturers, the calibration setup will remain generally the same. Keep in mind, for these conducted RF immunity tests, grounding is especially important, so it's crucial that those adapters have good connections to the ground plane. Let's go ahead now and let's take a look at the test setup. Now we're taking a look at the test setup using the KEMZ 801A. It's similar to that of the calibration setup, with the adapters and rod removed and replaced with the cables for the equipment under test. As you can see, we also are still using our 6 dB attenuator from the amplifier output of the NSG 4070. Taking a look now at the KEMZ 801A, it has a label for the direction of the equipment under test. This can be seen in the lower right-hand corner in front of the unit. The way we currently have the equipment set up, the EUT would be placed on the right side and the auxiliary equipment would be placed on the left. You will also notice on the side we have the FTC 101 decoupling clamp. This can be placed in the setup to help isolate the auxiliary equipment. Now we can go ahead and run the test, and it will apply the calibrated stress levels to the cabling going towards the equipment under test. Alright, that should complete the video today on electromagnetic clamps, also called EM clamps. We began the video by going over a little bit about the typical electrical specifications. Then we moved to the commonly needed equipment and accessories, and then finally we spent some time on the setups. We hope this video has been useful, and please keep us in mind if you ever need to rent conducted RF immunity test equipment, including EM clamps.